Today we will be talking about sentence transformer. So what is the sentence transformer, how it works, why we need to have a sentence transformer, all the things we will try to see in today's discussion. So stay focused because this is the first time that I'm going to cover this, and I will go a bit in detail. I don't want to cover the breadth, but I want to focus more on the depth part. So we will see how it works as well as how to train a sentence transformer for your own use. How can we use pre-trained sentence transformer? All the things we will try to cover in this video. So let's start with the first thing first. What is a sentence transformer? So by definition, if you will see, a sentence transformer is a Python framework. We know what is the framework, right? We will try to go in detail in whatever we are saying. Okay, it's a Python framework for state of the art sentence, text and image embeddings. To embed our sentences, text or images, we use this framework. But then the next question comes, what is the embedding? Because a term came here as embeddings. What is the embedding? So you might be aware that to train any machine learning model, we can't directly feed the textual data or images or your sentences to it. You have to convert these textual data, images or sentences into some type of numbers that a model can understand. Any machine learning model will work only on numbers. So once you convert that textual data to numbers, then you can feed it to the model. So that's why we need to come up with, there are multiple techniques how you can encode your data from text to embeddings, text to different formats, text to numbers, you can say. So embedding is coming from there. So basically you want to translate your textual information into some type of numbers. You can consider it this way. Now the next question is, what are the different types of embeddings that we have? We are actually having multiple types of embeddings if you will try to think in textual domain in NLP. So one is the kind of, I don't want to go much in detail, but to understand it, based on, like, this is the example that we are having. Sentence was, he goes to school. Okay, this sentence we can't directly feed to the model, then we have to convert this sentence into some embeddings. There are embeddings like TF-IDF vectorization, count vectorizer or word to vec or sentence vectorizer, like we are coming to that. So there are multiple ways we can encode it. So but the easiest way could be like we want to represent it in some kind of vector format. Now, so we got it clearly, right? So sentence transformer is nothing but it's a kind of Python framework that will give us the state of the art sentence, text or image embeddings. Okay. Now the next question that comes to our mind is basically how to train a sentence transformer. So training a sentence transformer is different from our traditional way of dealing the things. So let's go to the paper where they mention that how to train a sentence transformer. Let me quickly go to the paper. So here as you can see, we will be passing pair of sentences to the model. So it's a Siamese based network. We will be having two BERT models. We will pass sentence A and sentence B to these models. Once we will pass these sentences to these models, they will generate embeddings. Okay, if our maximum length in this case is, let's take for example 100, then the embedding size will be 100 cross 768 if we consider the 768 embeddings, okay. BERT usually gives us the 768 embeddings. So we will be getting 100 cross 768 embeddings out of it. Here also we will be getting 100 cross 768. But the next question that you can ask is basically if the sentence size is of 2 tokens or 3 tokens, so what will be the embedding size in that case? So again it will be 100 cross 768 because you have mentioned that your maximum sequence length is 768, right. So whenever you will not be having any tokens, it will consider them as 0. Whenever you will be having some tokens, we will be having embeddings related to that. Clear? Now once we have 100 cross 768 embeddings here, 100 cross 768 embeddings here, we will apply pooling on top of that. Pooling is nothing but it's just will take the average of that embeddings. For example, let's come back here and try to understand it in more detail. For example, we are having a sentence, he goes to school, okay. What our BERT model will do, it will give us embeddings related to this he, okay. So let's take an example. Rather than giving 768 embeddings, for simplicity I am taking embedding as 5 dimension embeddings or 3 dimension embedding for simplicity. So it will be something like 1 to 1, 1 to 3. For goes also, he goes to school, it will try to give, it will first tokenize and then give us the embedding. So let's say some 2, 3 and 4. Similarly for 2, it will give embeddings as 2, 5 and 6. For school also, embeddings like 6, 7 and 8. So the final size of these embeddings will be, if we are considering maximum sequence length as 4, then it will be of size 4 cross 5, right. In the pooling layer, what we do in the pooling, we have different type of pooling like min pooling, max pooling or average pooling. We generally take average pooling in case of sentence transformer. So we take this dimension, take the average of it. So 2 plus 1, 3 plus 2, 5 plus 6. So it will be 6 by 4. 6 by 4. 11 by 4, sorry. 11 by 4 and then 17 by 4, then your 21 by 4. This will be your pooled output. We used to call it pooled output. So what will be the dimension of this one? This pooled output, the dimension will be 1 by 3. Sorry, here also we will be having 4 cross 3. So you are just taking all the dimensions, 0 dimension, 1 dimension, 2 dimension and taking the average of it, and this will be our pooled output. Okay, let's back to the paper, go back to the paper that we were discussing. Then we will be having this pooled output as u vector and v vector. Then what we do, we try to optimize it based on the kind of loss function that we were choosing, but consider it this way, that if both the sentences are pretty much similar, then we will give a closure score. Okay, in that case what will happen, that this score will be 1. If both the sentences are dissimilar, we will give it as a 0, and we will try to optimize the weights of these BERT models based on that. Okay, so it will try to understand that these two sentences are similar and these two sentences are dissimilar. That's what we are going to train this model on. Okay, I hope that is clear. Now that part is clear. How can we train the sentence transformer? Now let's go to the next part, that is basically how to use a sentence transformer. What we need to do to use a sentence transformer. So to use a sentence transformer, we need to understand where we can use it. Second, how can we basically train our own sentence transformer. Okay, to use a sentence transformer, let me go to the notebook here. You have to install it. So you can simply do pip install -u sentence transformer and it will install it for you. Now from the sentence transformers library, you can take a pre-trained model. That model, like I just discussed, was also being trained on similar sentences pairs. Okay, and they have put it here in sentence transformer. You can check it from Hugging Face also. Okay, once the model is downloaded, then we will be passing some sentences to these models, sentence A, sentence B, sentence C, and what this model will give us, it will give us the embeddings related to these particular sentences. Okay, so if we'll just we will do model dot encode and pass all the sentences, then we will get the embeddings, and those embeddings we can see sentence by sentence. Okay, so for example, this was our first sentence. This framework generate embeddings for each input sentence, and the embedding that we are getting is this one. What will be the size of embedding? The size of embedding will be 768. Correct? Yeah. Then we can go to the next sentence. This is my next sentence, and this is the embedding that it will be generating. Okay, so whenever you try to convert a particular text, paragraph, or any kind of textual information, then you can use these kind of pre-trained models to convert it into embeddings and feed it to your model to further downstream tasks like sentiment analysis, like classification, regression, anything you want to do. Okay, so I hope that is clear. How can we use a pre-trained model? Now the next thing is basically how can we train our own sentence transformer. So for that we used to have some similar sentences pairs dataset available, and we can directly train a model, sentence transformer model from scratch. We will try to cover that part in the next discussion. Also we will try to cover that taking some sample data, how can we train our sentence transformer model, and how the embeddings will be different from the pre-trained models ones. Okay, so I hope you like the video. If you like it, just mention in the comment. If there is any topic that you want me to cover in text or NLP, then definitely let me know. Thanks for your time. See you in the next video.